primarily we are going to focus on what all are features of the cloud. We are going to discuss about what all are different features of the cloud. That is the topic which we are going to cover as part of our today's session. So we can able to say first feature of the cloud is nothing but within the cloud we can able to get distributed framework. As part of using the cloud, you can able to get the distributed framework. What is the meaning of distributed framework? Very simple statement. We can able to say like this: whatever the load we are getting, if we are distributing that load equally across all the nodes, such kind of process we can call it as distributed framework. A very simple statement. Just we can able to say whatever the load of the work we are getting, if you are distributing that work equally across all the nodes, such kind of process we can able to call it as nothing but distributed framework. We'll see one general example. For example, see from the government side, they want to construct 1,000 apartments, and to complete this big project, they are giving this entire project to, for example, L&T builders. So actually from the government side, they want to construct 1,000 apartments, and to complete this big project, they are giving this entire big project to, for example, L&T builders. Now only L&T builders are going to construct all these 1,000 apartments. Now only if L&T builders are going to work, what will happen? To complete this entire project, for example, it is going to take 5 years of time. But here government requirement is, they don't want to wait for 5 years. They want to complete this project within 2 years. That is their requirement. From the government side, the requirement is they want to complete project within 2 years. For the reason, what they did here is, instead of giving this entire work to only L&T builders, they introduced one more builder, for example, XYZ builders, and they introduced one more builder called as a ABC builders. Like that, they given the same project to the multiple builders. Instead of giving the same work to one builder, they given this project to the multiple builders. Now what all these builders are going to do here is, they are going to distribute the work. For example, these people are going to construct 300 apartments, and XYZ builder is going to construct, for example, 350 apartments, and ABC builder is going to construct, for example, 350 apartments. Like that, what they are going to do here, they are going to distribute all the apartments equally across each and every builder. At the same time, all these builders are going to work in the parallel manner. All these builders are distributing work themselves, and also they are working on these apartments or this project in parallel manner. So what is the meaning of parallel manner? This builder is working on 300 apartments, this builder is working on 350 apartments, this builder also working on 350 apartments. Like that, all these people are going to work in the parallel manner. Now, because of distribution of the work to the 3 different builders, and also because of doing all the work in the parallel manner, now within how much time we can able to complete the project? Same project we can able to complete either within 2 years or 2.5 years. We can able to complete the same project. Instead of taking the 5 years of time, within 2 years only we can able to complete the project. But to complete the project within 2 years of duration, what activities we have done here? We distributed this entire project to the multiple builders. All these builders are going to work on individual apartments in parallel manner. Because of the reason, instead of taking the 5 years of time, within 2 years of time we can able to complete the project. Indirectly we can able to say, as part of this example, we are applying distribution activity. We are distributing same project to the multiple builders. Because of the reason, you can able to complete your entire project within small duration of the time. That is the meaning of your distribution of the load across multiple people by depending on our requirement. That kind of framework we can able to call it as nothing but our distributed framework. For our easy understanding, I am giving this generic example. Now we'll try to understand one real-time example. By using real-time example, you can able to understand what is the meaning of our distributed framework. Whatever the example here I am giving, this is for our easy understanding. I am giving the generic example. Now by using real-time example, we'll try to understand. Just one second. Now see, for example, you are having a cluster, and in this cluster, for example, you are having single virtual machine, and for this machine, for example, you are having networking. Just assume that you are having a cluster. What is the meaning of cluster? Cluster is nothing but a group of the machines. We can able to call it as a cluster. For example, you are having the cluster, but in this cluster, you are having the single machine. Now your requirement is, on top of this cluster, as per our requirement, I want to load data for load 100 GB file on this cluster. That is my requirement. So what is the requirement here? I want to load 100 GB file on top of this cluster. But if you observe here, in this cluster, how many virtual machines we are having? You are having single virtual machine. What it means indirectly, whatever the data you are trying to load, all this 100 GB data is going to load on top of your single virtual machine. Whatever the 100 GB data you are loading, that entire data is going to load on top of the single virtual machine. For this, I can able to say, to complete this loading operation, it is going to take, for example, 10 minutes of time. Why it is taking 10 minutes? For example, as part of this cluster, you are having the single virtual machine. For that reason, to load the data on top of the single virtual machine, it is taking total 10 minutes of time. Now my requirement is, I want to complete same data loading activity within 2 minutes of time. For that, just what I'm going to do here is, I am going to create a cluster. In this cluster, I am going to maintain multiple virtual machines. So for example, here I'm having virtual machine 1, virtual machine 2, virtual machine 3, and virtual machine 4. In between all these virtual machines, we are going to maintain the communication by using networking. So we are having total 4 different virtual machines. In between all these virtual machines, we are going to maintain the communication by using a networking. Now you are having the cluster with 4 virtual machines. Now, for example, now you try to give the answer. If I am going to load that data for 100 GB file on top of this cluster, now where the data is going to store? Any guesses I'm asking? If I am loading this 100 GB file on top of this cluster, now this 100 GB data is going to store on top of single machine, or this data will distribute to all the machines automatically?
All 4.
It will distribute the data to all the machines automatically. Indirectly, here it will take 25 GB data. Here it will take 25 GB data. Here again 25 GB. Here also 25 GB. Like that, your data distribution is going to happen on top of your each and every virtual machine. At the same time, as part of loading this 25 GB data, your data loading sequentially or parallelly. Any guesses again? Your data loading in parallel manner. Indirectly, if you observe here, whatever the data you are loading, that data is going to distribute to each virtual machine in parallel manner. Earlier, what's happening here? You are having the single machine. In the single machine, complete 100 GB data is loading. But in this example, I am having the multiple virtual machines. For that reason, as part of loading the data is going to distribute on top of your each and every virtual machine. At the same time, this operation is going to happen in parallel manner. Now you tell me, on top of this cluster, now if you are loading the data, how much time it will take? Will it take 10 minutes or will it take the less amount of time?
Less time.
Less amount of time. We can able to say 2 minutes, or for example, we can able to say 3 minutes of time, because here you are going to maintain the multiple clusters, multiple virtual machines in the cluster. At the same time, whatever the data you are loading, that data distributing on top of your every virtual machine in parallel manner. Because of that reason, automatically you can able to complete this operation within 3 minutes of time. But tell me, how your cluster can able to understand I need to distribute the data to all the virtual machines? Do we need to perform any operations manually here? As a user, do I need to perform any operations manually to distribute the data to the multiple virtual machines?
No.
No need to perform any kind of operations manually, because on top of the cloud, you are having the feature. What is the feature we are discussing? We are discussing the feature called as nothing but distributed framework feature. Because of having this feature, as a user from your side, no need to perform any kind of activities. Whenever you are trying to load the data on top of this cluster, automatically what will happen? Your data distribution is going to happen for multiple machines. At the same time, your data is going to load in parallel across all the virtual machines automatically. As a user, no need to perform any manual operation. Everything is going to happen automatically on top of the cloud. That is the advantage of the cloud, or that is the beauty of the cloud. And that kind of feature, simply we are calling it as nothing but our distributed framework feature. Okay. And if you observe here, so far we are discussing about loading the data. For example, I loaded the data on top of this cluster, which is having one virtual machine. After loading the data, my requirement is I want to retrieve the data. In the real time, what will happen? You will load the data. At the same time, you will retrieve the data. And now my requirement is I want to retrieve the data from this cluster. Now you tell me, from this cluster, if you want to retrieve the data, again, how much time it will take? How many machines we are having? Single virtual machine. Within the single virtual machine, you are having complete 100 GB data. Now, if you want to retrieve the data from single virtual machine, again, automatically what will happen? It will take, for example, 10 to 12 minutes of time on top of this cluster. Instead of that, for example, you are having cluster like this. Now from this cluster, you want to perform the retrieve operation. Now you tell me, on top of this cluster, if you are going to perform the retrieve operation, how much time will it take? Will it take 10 to 12 minutes, or it will take the less amount of time?
2 to 3.
can able to say, for example, 2 to 3, or I can able to say 3 to 4 minutes of time. What is the reason? Here we are not having the 100 GB data on top of the single machine. The data distributed on top of your each and every machine. That is the reason, as part of retrieving the data, it is trying to retrieve the data from each and every machine. Again, tell me, your data retrieval is going to happen sequentially or parallelly again?
Parallel.
Data retrieval also going to happen in parallel manner. Indirectly, what I'm trying to say here is, as part of loading, distribution framework feature will come into the picture. Your data is going to load in parallel manner. In the same way, as part of retrieving the data also, your distribution framework is came into the picture. At the same time, it is going to perform retrieval operation in parallel manner. Because of that reason, as part of doing retrieval operation, you can able to save the time. So overall, we can able to say the statement here like this: while performing loading operations or retrieval operations, it will apply distributed framework feature. With that, it will perform all the operations in parallel manner, and because of that, because of this reason, we can able to see, or we can able to get very good performance. So because of distribution framework feature, all the operations are going to happen in parallel manner. Because of that reason, automatically what is going to happen, you can able to get the performance, very good performance. And also by using this example, primarily we need to understand, because of having the 4 virtual machines, your entire loading is going to happen in the distributed manner. Because of having the 4 machines, as part of retrieval also, load is going to be distributed. Because of that reason only, you can able to see the good performance. That kind of feature only we are calling it as nothing but our distributed framework feature. As part of this distribution activity, as part of this parallelism activity, as a user, no need to perform any manual activities here. Automatically cloud is giving this kind of distributed feature. Automatically cloud is going to take care of this kind of parallel execution. That is the reason that feature simply we can able to call it as a distributed framework feature. Now if you observe here, on top of this entire example, just we are using 2 new terminologies. One we are calling it as a cluster, other one we can able to call it as a virtual machine. Just I want to give some understanding. What is the meaning of cluster? Cluster is nothing but simply we can able to say group of nodes, or we can call it as a group of machines. Cluster is nothing but we can able to call it as a group of nodes, or we can able to call it as a group of the machines. And also I am using one more terminology called as a VM, or we can call it as a virtual machine. Virtual machine is nothing but, for example, see, you are using your personal laptop. Your personal laptop, we can able to call it as a physical machine. Why we are calling it as a physical machine? You are having laptop in front of you. Within the laptop, you are having physical hard disk. You are having the physical RAM. Like that, everything you are going to maintain physically. That is the reason. In general, laptop we can able to call it as a physical machine. Now, with the help of the cloud, you can create your machines over the internet. What we can do here, simply over the internet, you can able to create your machine. Just we have to give few inputs. I want to get RAM 8 GB. I want to get hard disk, for example, is nothing but 100 GB. Like that, by giving some basic inputs over the internet with the help of the cloud, you can able to create a machine. But whatever the machine you are creating on top of the cloud, that machine indirectly we can able to call it as nothing but virtual machine. Because as part of creation of the machine over the internet, that machine you cannot able to see physically, you cannot able to see RAM physically, you cannot able to see hard disk physically. This RAM and hard disk, everything is going to maintain by your cloud platform. Just you can able to access the machine over the internet. Physically you are not accessing. Over the internet you can able to access the machine. Such kind of machines we can able to call it as a virtual machine. Indirectly we can able to say virtual machine is equivalent to your laptop. Only difference is nothing but laptop you can able to physically see, physically you can able to do the operations on top of the laptop. But coming to virtual machine, this machine you are creating over the internet with the help of the cloud. That is the reason such kind of machine simply we can able to call it as a virtual machines. Okay, why I'm explaining about this here is, as part of our example, I introduced 2 different terminologies. One is cluster, one is VM. Might be non-experienced people cannot able to understand what is the cluster, what is the virtual machine. That is the reason just I'm giving some brief info about what is the cluster, what is the virtual machine. But primarily here we need to understand, on top of the cloud side we are having one of the feature called as nothing but our distributed framework feature. Because of having this feature, we can able to get very good performance as part of using our cloud. Okay, in the same manner, on top of the cloud, we are having one more important feature which we can able to call it as nothing but scalability feature. On top of the cloud, we are having one more feature called as a scalability feature. Very simple. What is the meaning of scalability? Is nothing but as per your requirement, if you can able to increase or decrease number of resources on the fly, such kind of activity we can call it as scalable. based on your requirement. If you can able to increase or decrease number of resources on the fly, such kind of activity we can able to call it as a scalability. Again, if you observe here in this statement, I am using a new terminology called as a resources. We'll try to explain, we'll try to understand what is the meaning of resources. Again, to understand the scalability, first we'll try to understand generic example. With that, we'll try to understand real-time example. For example, see, from the quality thought side, we are conducting a demo. And for this demo, for example, we expected 40 students and we arranged 40 chairs. But because of some reason, on the demo day, suddenly 60 students came into the picture. Actually, how many students we expected? 40 students. How many chairs we arranged? Only 40 chairs. But suddenly 60 students came for the demo. And here we are having a classroom with capacity of 100 students. But coming to demo, how many students are came? 60 students. But how many chairs we arranged? Only 40 chairs. Now, to accommodate the 60 students, what we are going to do here is simply we are increasing number of chairs from 40 chairs to 60 chairs. Okay, all these are happening on top of the day one. On the day one demo, this is the situation we faced here. For example, based on this experience, what we are doing here is coming to day two. Again, we are conducting the demo. Coming to second day, for example, we expected 60 students and we arranged 60 chairs. But because of some reason, on the day two, suddenly 80 students attended the demo session. For that reason, to accommodate all the students, again, what we are going to do, we are going to increase number of chairs from 60 to 80 chairs. With that, we are accommodating all the 80 students for the demo. In the same manner, for example, coming to day three. Now we expected 80 students, and we arranged 80 chairs. But because of some reason, 130 students are came for the demo. Now we are going to increase number of chairs from 80 to 130. But tell me, is it possible? No. This scenario is possible, and this scenario also possible because my classroom capacity is nothing but 100 students. For that reason, I can increase number of chairs from 40 to 60 or 60 to 80. But to accommodate 130 students, can I able to increase number of chairs from 80 to 130? Is it possible? Obviously, it is not possible. For that reason, what we are going to do here is we are moving from this classroom to other classroom, which is having, for example, 150 students capacity. Indirectly, if you see here as part of this example, primarily what we need to understand here is based on the number of students, we are increasing number of chairs. Initially, we maintained only 40 chairs. After that, we increased it to the 60 chairs. After that, we increased it as a 80 chairs by depending on our number of students in the class. Indirectly, as per our requirement, on the fly, we are increasing number of chairs. In this example, this chair we can able to call it as nothing but resources, and whatever we are increasing as part of this example, that kind of activity we can able to call it as a scalability. By depending on the number of the students, we are increasing number of chairs from 40 to 60 or 60 to 80 or 80 to 130. Like that, we are increasing number of chairs by depending on the requirement. That kind of activity simply we can able to call it as a scalability activity. For our easy understanding, I am giving this example to understand what is the meaning of the scalability. Now again, we'll try to understand one real-time example on about what is the meaning of scalability. For example, see here. Now this is my cluster. Now from this cluster, or I can able to say, for example, just 1 second. Now this is my cluster, for example, here. Now in this cluster, I am going to retrieve the data. But if you see here, as per the above example, as part of retrieving the data, how much time it is going to take? For example, 3 to 4 minutes. Okay. Now my client requirement is he want to complete retrieval operation within 1 minute. For example, that is my client requirement. He want to complete the data retrieval operation within 1 minute. Now you tell me what is the possibilities we are having to complete this retrieval operation within 1 minute. Any guesses?
More machines you can add. Then
very good answer. Very good answer. I can able to say simply what we can do here. Just in this cluster, as per the client requirement, if you want to complete your retrieval operation within 1 minute, just what we can do here, instead of having the 4 machines, I am going to maintain, for example, total 8 number of machines. For example, what I'm doing here, instead of having the 4 machines, I am going to increase number of machines from 4 to 8. Just 1 second. And in between all these machines, we are going to maintain the communication with the help of the networking. Now, indirectly, as part of our requirement, I want to perform a retrieval operation within 1 minute. For the purpose of achieving that requirement, now we are increasing number of machines from 4 to 8 as part of this example. Now, whenever you are increasing number of machines from 4 to 8, automatically what will happen? In each and every virtual machine, it is going to load 12.5 GB data, 12.5 GB. Like that, your data distribution is going to happen on top of your all these machines. Now,